We're going to talk about some characteristics of quadratic functions. Now, most of these are going to be familiar to you, but there are 4 new terms that you need to be familiar with. So the first term I want you to be aware of is one called the vertex. The vertex is the turning point of your parabola. It's either the highest point or the lowest point. If you look at these two functions we have here, this, would be your vertex. So on this parabola, it's the lowest, and on the one on the right, it's the highest point. There's also something we have called the axis of symmetry. The axis of symmetry is your line that divides your parabola in half. It goes right through your vertex. So these yellow lines here, these are your axis of symmetry. And you write the equation for the axis of symmetry as a line. So it would be like x equals, and then whatever x value it's going through. All right, we also have what we call a minimum or maximum value. That is your highest or lowest point of your parabola. The highest point is your maximum. Your lowest point is your minimum. And again, we have the vertex here labeled as either maximum or minimum. And then finally, the last thing we have are x-intercepts. The x-intercept is where the place where your parabola either crosses or touches your x-axis. There might be 0, 1, or 2 x-intercepts. And so here, we can see where we cross our x-axis. Both of these parabolas have 2 intercepts. So what you're going to be expected to do is take this information and apply it to these quadratic functions. So let's look at this graph over here. We want to label our vertex. When we're asked to label our vertex, what we're doing is we're writing the ordered pair of our vertex. This is my vertex here. So the ordered pair for this vertex, I'm going to go over 2 and down 1. So the vertex is at 2, -1. Now my axis of symmetry, remember, that's the line that divides my parabola in half. That's right here. We write this axis of symmetry as an equation. So right here, this is where x equals 2. And what you'll notice is that axis of symmetry goes right through your vertex. So the x value of your vertex is the axis of symmetry. All right, we need to talk about whether it's a minimum or a maximum. Our vertex here, is this our highest point or the lowest point of our parabola? Well, if we think of it like a bowl or a valley, the vertex is at the very, very bottom of it. So we would say this point is a minimum. Okay, now increase and decreasing intervals. This is probably the thing that's the trickiest. And if we look at our axis of symmetry, it can help us out. So if my axis of symmetry right here is where x equals 2, what I want you to think about is everything on the right side then is where x is greater than 2. And everything over here on the left side is where x is less than 2. Now these are the intervals we're going to use when we talk about whether we're increasing or decreasing. We just have to figure out which side of our parabola increases and which decreases. Now parabolas are read from left to right, so I'm going to start here. And what I want you to do is kind of trace your parabola and see what it's doing. As I trace this, it's going down and down and down. If it's going down, this side is our decreasing side. Okay? So I put a big D there so we can see it's decreasing. So my decreasing interval is everywhere on this side of the vertex, everywhere where x is less than 2. Now if I continue to trace that parabola from my vertex on the right side here, it keeps going up, 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 which means this side is my increasing side. So my increasing side is where x is greater than 2. All right, your domain and your range. Your domain is going to always be, for these kinds of parabolas, unless they're word problems, we're talking about all real numbers. We're talking about every number from -infinity all the way to +infinity. What that means is I could plug in any x value into this parabola and get a y value that would be part of this parabola. So there are no limitations on my x value, so from -infinity to +infinity. Our range, though, is limited. If we look at this parabola, we know this vertex right here, this is our minimum value, which means I can't have anything that's down here below that minimum value. All of my values have to be above or greater than this vertex. So if you think of it that way, your vertex, the y value of the vertex, is here at -1, and we said all the values of this vertex are above it or greater than, so the range is greater than or equal to -1. And then finally, last but not least, if we talk about our number of x-intercepts, the x-intercepts are the places where we either cross or touch our x-axis. So in this case, we have 2 x-intercepts, and we would just write 2.